Bismillahirrahmanirrahim. Today, the topic of my presentation is regression analysis. I am Dr. Abhay Nazim and I am presenting under the kind supervision of Professor Dr. Saira. You will face many defeats in life, but never let yourself be defeated. Learning objectives. Definition, type, uses, limitations, residual plot analysis, simple linear regression, and multiple linear regression. Learning outline. Simple and multiple linear regression, introduction of regression analysis, difference between correlation and regression, types, uses, and limitations. Contents. Introduction. The dictionary meaning of the term regression is the act of returning or going back. The term regression was first used by Sir Francis Galton in 1877 while studying the relationship between the height of fathers and sons. This term introduced by him in the paper Regression Towards Mediocrity in Hereditary Stature. Regression is the measure of average relationship between two or more variables in terms of original units of data. The term regression analysis refers to the methods by which estimates are made of the variables from a knowledge of values of one or more other variables and to measurement of errors involved in the estimate. Difference between correlation and regression. Correlation coefficient is a measure of degree of covariability or association between x and y. Regression. The objective of regression analysis is to the study of nature of relationships between the variables so that we may be able to predict the values of one on the basis of another. Correlation is merely a tool of ascertaining the degree of relationship between two variables, and therefore we cannot say that one variable is the cause and the other is the effect. The variables may be affected by some unknown common factor. In regression analysis, one variable is taken as dependent while the other is independent, thus making it possible to study the cause and effect relationship. Correlation coefficient is independent of change of scale and origin. Regression coefficient is independent of change of origin but not of scale. In this RxY is a measure of direction and degree of linear relationship between two variables x and y. Rys and Rxy are symmetric. It is immaterial which of x and y is dependent variable and which is independent variable. In regression analysis, the regression coefficients Bxy and Bys are not symmetric and hence it definitely makes a difference as to which variable is dependent and which is independent. Types of regression. Linear regression, logical regression, polynomial regression, stepwise regression, bridge regression, and lasso regression. Methods of studying regression lines. There are two methods, graphical and algebraical. Graphically, we study it in the form of freehand curve and least squares, and algebraically, we divide it into three parts, least squares, deviation method from arithmetic mean, and deviation method from assumed mean. In the first part of this section, we find the equation of straight line that best fits the paired sample data. That equation algebraically describes the relationship between two variables. The best fitting straight line is called a regression line and its equation is called the regression equation. Simple linear regression. Regression equation. Given a collection of paired sample data, that regression equation that exactly describes the relationship between the two variables x and y is y hat is equal to b naught plus b1x. The regression equation attempts to describe a relationship between two variables. Inherently, the equation algebraically describes how the values of one variable are somehow associated with values of other variables. Regression lines The graph of the regression equation, also known as the line of best fit or the least square model, also known as the line of best fit or the least square line, the regression line fits the same points best. Notation, population parameter and sample statistics. Notice that the y hat in the sample regression equation, this implies that we are predicting something. We are predicting values of y based upon the true and observed values of x. Requirements for simple linear regression. The sample of paired data is a simple random sample of quantitative data. The pairs of data x, y have a bivariate normal distribution, meaning the following. Visual examination of the scatter plots confirm that the sample points follow an approximating straight line. Because results can be strongly affected by the presence of outliers, any outliers should be removed if they are known to be errors. Use caution when removing data points. Formula for D0 and D1. D1 is R into Sy divided by Sx, where Sy and Sx are the standard deviations of y values and x values. Intercept. D0 is equal to y bar minus D1 into x bar. Software will typically be utilized to calculate these coefficients. We would like to use the explanatory variable x, blueprint length, to predict the response variable y, height. The data are listed below. The data are assumed to be a simple random sample. The scatter plot shows a roughly straight line pattern. There are no outliers. The use of technology is recommended for finding the equation of a regression line. Using stat runs, we obtain the following results. Simple linear regression results. Dependent variable height, independent variable footprint, and height has the following values. So then the regression equation can be expressed as y hat is equal to 125 plus 1.734. Graph the regression equation on a scatter plot. Using the regression equation for prediction. Use the regression equation for predictions only if the graph of the regression line on the scatter plot confirms that the line hits the points reasonably well. Use the equation for predictions only if the data used for prediction does not go much beyond the scope of the available sample data. Use the equation for prediction only if R indicates that there is a significant linear correlation indicated between the two variables x and y. If the regression equation does not appear to be useful for predictions, the best predicted value of a y variable is its point estimate. That is, the sample mean of the y variable would be the best predicted value for that variable. The strategy for predicting values of y. If following qualities are present, then it will be a good regression model. The regression line graph in the scatter plot shows that the line fits the points well. R indicates that there is a linear correlation. The prediction is not much beyond the scope of the available sample data. If these qualities are present, then it is a good regression model. Substitute the given value of x into the regression equation y hat is equal to d0 plus d1x. And if these qualities are not present, then it is not a good regression model. Regardless of the value of x, the best predicted value of y is the value of y bar, the mean of the y value. Marginal change. Marginal change in working with two variables related by a regression equation. The marginal change in a variable is the amount that the variable changes when the other variable changes by adjusting one unit. The slope v1 in the regression equation is the marginal change in y when x changes by 1 unit. For the 40 pairs of two field length and height, the regression equation was y hat is equal to 80.9 plus 3.22. The slope of 3.22 tells us that if we increase two field length by 1 cm, the predicted height of a person increases by 3.22 cm. Scatter plot. Plot of paired quantitative data with a dot representing each pair of points, helping in determining whether there is a relationship between two variables, weight circumference and arm circumference in use. Time series graph. Quantitative data collected over time and plotted accordingly with a horizontal axis representing some measure of time. Background definition concept. Outlier. In a scatter plot, An outlier is a point lying far away from the other data point. Influential point. A point that strongly affects the graph of the regression line. For 40 pairs of two prints and height, observe what happens if we include this additional data point. X is 35 cm and Y is 25 cm. Original paired two-print and height data. Two-print and height data with an additional point. The additional point is an influential point because the graph of the regression line did change considerably. The additional point is also an outlier because it is far from the other point. Residual and the least squares property. Residual. For a pair of sample x and y values, the difference between the observed sample value of y and the y value that is predicted by using the regression equation is the residual. Residual is observed minus predicted y minus y hat. A residual represents a type of inherent prediction error. The regression equation does not typically pass through all the observed data values that we have. The least squares property. A straight line satisfies this property if the sum of the squares of the residuals is the smallest sum possible. Residual plot. A scatter plot of the xy values after each of the y values has been replaced by the residual value y to y third. That is, a residual plot is a graph of points x, y minus y. Residual plot analysis. When analyzing a residual plot, look for a pattern in the way the points are considered and use these criteria. The residual plot should not have any obvious pattern, not even a straight line pattern. This confirms that the scatter plot of the sample data is a straight line pattern. The residual plot should not become thicker or thinner when viewed from left to right. This confirms the requirement that for different fixed values of x, the distributions of the corresponding y values all have the same standard deviation. The two-print and the height data are used to generate the following residual plot. The residual plot becomes thicker, which suggests that the requirement of equal standard deviation is violated. The following slide shows each residual plot. Let's observe what is good or bad about the individual regression model. Regression model is good model. Residual plot suggesting that the regression equation is a good model. And residual plot with an obvious pattern suggesting that the regression equation is not a good model. Residual plot that becomes thicker suggesting that the regression equation is not a good model. Complete regression analysis. Construct a scatter plot and verify that the pattern of the point is approximately a straight line pattern without outliers. If there are outliers, consider their effects by comparing results that include the outliers to results that exclude the outliers. Construct a residual plot and verify that there is no pattern other than a straight line pattern, and also verify that the residual plot does not become thicker or thinner. Use a histogram or normal quantile plot to confirm that the values of the residuals have a distribution that is approximately normal. Consider any effects of a pattern over time. Multiple linear regression. We will look at a method for analyzing a linear relationship involving more than two variables. We focus on these key elements: finding the multiple regression equation, the value of the adjusted R-square, and the p-values as measure of how well the multiple regression equation fits the sample data. Multiple regression equation and line. Multiple regression equation. Given a collection of sample data with several explanatory variables, the regression equation that algebraically describes the relationship between the response variable y and the two or more explanatory variables x1, x2 to xk, and is y hat is equal to b0 plus b1 x1 plus b2 x2 plus bk xk. We are using more than one explanatory variable to predict a response variable now. In practice, you need large amounts of data to use several predictor or explanatory variables. Your sample size should be 10 times larger than the number of x variables. Multiple regression lines, the graph of the multiple regression equation. This multiply regression line still fits the sample points best according to the least squares property. Visualization. Multiple scatter plots of each pair x, k, y of quantitative data can still be helpful in determining whether there is a relationship between two variables. These scatter plots can be created one at a time. However, it is common to visualize all the pairs of variables within one pair. This is often called a pair plot, pairwise scatter plot, or scatter plot magic. Here is the notation for population parameter and sample statistics. Y hat is the predicted value of y. K is the number of predicted variables, also called independent variables or XVariables. Requirements for regression and formulas for PK. Requirements for regression. The sample data is a simple random sample of quantitative data. Each of pairs of data x, k, y have a bivariate normal distribution. Random errors associated with the regression equation, that is residuals, are independent and normally distributed with a mean of 0 and a standard deviation 6. Formulas for BK. Statistical software will be used to calculate the individual coefficients estimate BK. Selecting the best multiple regression equation for prediction. Use common sense and practical considerations to include or exclude variables. Consider the p-values for the test of overall model significance. Hypothesis. Null hypothesis is B1 is equal to B2 is equal to Bk is equal to 0. And alternate hypothesis is at least one Bk is not equal to 0. Test statistics F is equal to Ms into regression divided by Ms into error. This will result in an ANOVA table with a p-value that expresses the overall statistical significance of the model. Selecting the best multiple regression equation for prediction. Consider equations with high adjusted R-square value. R is the multiple correlation coefficient that describes the correlation between the observed y values and the predicted y hat value. R squared is the multiple coefficient of determination and measures how well the multiple regression equation fits the sample data. Problem. This measure of model fitness increases as more variables are included until it can usually rate no more or only by a very little amount, no matter how significant the most recently added predictor variables is. Adjusted R-squared is the multiple coefficient of determination that is modified to account for the number of variables in the model and the sample. Selecting the best multiple regression equation for prediction. Consider equations with the fewest number of predictors explanatory variables if models that are being compared are nearly equivalent in terms of significance and space, that is p-value and adjusted R-square. This is known as the law of parsimony. We are looking for the simplest yet most informative model. Individual t-tests of particular regression parameters may help select the correct model and eliminate insignificant explanatory variables. If the regression equation does not appear to be useful for predictions, the best predicted value of a y variable is still its point estimate, that is the sample mean of the y variable would be the best predicted value for that mean. Complete multiple regression analysis. Identify the response and potential explanatory variables by constructing a scatter plot network. Create a multiple regression model. Perform the appropriate tests of the following. Overall model significance, the ANOVA, that is the SS, individual variable significance, t-test. In addition, find the following. Find the adjusted R-squared value to assess the predictive power of the model. Perform our residual analysis to verify the requirements for linear regression have been satisfied. Construct a residual plot and verify that there is no pattern other than a straight line pattern, and also verify that the residual plot does not become thicker or thinner. Examples are shown below. Residual plots suggesting that the regression equation is a good model. Residual plots with an obvious pattern suggesting that the regression equation is not a good model. Residual plots that become thicker, suggesting that the regression equation is not a good one. Use a histogram normal quantile plot or Shapiro-Wilk test of normality to confirm that the values of the residuals have a distribution that is approximately normal. Normal quantile plot, examples in the next few slides. Shapiro-Wilk normality test. This will help you assess the normality of a given set of data, in this case the normality of the residuals, then the visual examination of the QQ plot or the histogram of the data seen unclear to you and user's phone. Hypothesis. Null hypothesis is the data comes from a normal distribution. Alternate hypothesis, the data does not appear to come from a normal distribution. In case of normal distribution, histogram of IQ score is close to being bell-shaped, suggests that the IQ scores are from a normal distribution. The normal quantile plot shows points that are reasonably close to the baseline pattern. It is safe to assume that these IQ scores are from a normally distributed population. In case of uniform, histogram of data having a uniform distribution, the corresponding normal quantile plot suggests that the points are not normally distributed because the points show a systematic pattern that is not a straight line pattern. These sample values are not from a population having a normal distribution. In case of secured data, histogram of the amount of rainfall in Boston every Monday during 1 year. The shape of the histogram is skewed, not well-shaped. The corresponding normal quantile plot shows points that are not at all close to a straight line pattern. These rainfall amounts are not from a population having a normal distribution. Example, heights of mothers, fathers, and daughters. The table to the right includes a random sample of heights of mothers, fathers, and their daughters based on data from the National Health and Nutrition Examination. Find the multiple regression equation in which the response y variable is height of a daughter and the predictor x variables are the height of the mother and father. From the display, we see that the multiple regression equation is daughter is equal to 7.5 plus 0.707 that of mother and 0.164 of father. We could write this equation as y hat is equal to 7.5 plus 0.707 x1 plus 0.164 x2, where y hat is the predicted height of daughter, x1 is the height of the mother, and x2 is the height of father. The preceding technology display shows the adjusted coefficient of determination as R squared adjusted 63.7%. When we compare this multiple regression equation to others, it is better to use the adjusted R square of 63.7%. Based on spectrum, the p-value is less than 0.0001, indicating that the multiple regression equation has good overall significance and is usable for prediction. That is, it makes sense to predict the heights of daughters based on heights of mothers and fathers. The p-value results from a test of the null hypothesis that b1 is equal to beta 1 is equal to beta 2 is equal to 0, and rejection of this hypothesis indicates the equation is effective in predicting the heights of daughters. Predicting height from footprint evidence. Dataset 2 in Appendix B includes the age, hip length, footprint length, shoe size, and height for each of 20 different subjects. Using those sample data, find a regression equation that is the best for predicting height. The table on the next slide includes key results from the combinations of the 5 predictor variables. Here is the graph for predicting height from footprint evidence. Using critical thinking and statistical analysis, delete the variable age, delete the variable shoe size because it is really a rounded form of foot length. For the remaining variables of foot length and footprint length, select foot length because its adjusted R squared of 0.7014 is greater than 0.6520 for footprint. Although it appears that only foot length is best, we know that criminals usually wear shoes, so footprint lengths are likely to be found than foot length. Hence, the final regression equation only including foot length is y hat is equal to beta naught plus beta 1 into x1, where beta naught is the intercept Beta 1 is the coefficient corresponding to x1 variable, that is frequency. The methods of the above section, multiple linear regression, rely on variables that are continuous in nature. Many times we are interested in dichotomous or binary variables. These variables have only two possible categorical outcomes, such as male, success failure, or dead alive. Indicator or dummy variables are artificial variables that can be used to specify the categories of the binary variables, such as 0 for male and 1 for female. If an indicator variable is included in the regression model as a predictor explanatory variable, the methods we have are appropriate. However, can we handle a situation when the variable we are trying to predict is categorical and are binary? Notice that this is a different issue, but yes. Using a dummy variable. The data in the table also includes the dummy variables of sex coded as 0 for female and 1 for male. Given that a mother is 63 inches tall and a father is 69 inches tall, find the regression equation and use it to predict the height of a daughter and a son. Using technology, we get the regression equation. Height of child is 25.6 plus 0.377, that is height of mother, plus 0.195, height of father, plus 4.5 plus 10. We substitute in 0 for the sex variable, 63 for the mother and 69 for the father, and predict the daughter will be 62.8 inches tall. We substitute in 1 for the sex variable, 63 for the mother and 69 for the father, and predict the son will be 67 inches tall. Using of regression analysis. It helps in establishing a functional relationship between two or more variables. As most of the problems of economic analysis is based on cause and effect relationships, regression analysis is highly valuable tool in economics and business research. It predicts the values of dependent variables and independent variables. We can calculate coefficient of correlation and coefficient of determination with the help of regression strategy. Limitations of regression. In making estimates from a regression equation, it is important to remember that the assumption is being made that relationship has not changed since the regression equation was computed. Another point worth remembering is that relationship shown by the scatter diagram may not be the same if the equation is extended beyond the values used in computing equations. For example, there may be a closer linear relationship between the yield of a crop and the amount of fertilizer applied, with the yield increasing as the amount of fertilizer is increased. It would not be logical, however, to extend this equation beyond the limits of experiment, for it is quite likely that if the amount of fertilizer were increased indefinitely, the yield would eventually decline as too much fertilizer was applied. Now the time for MCQ. Suppose we are using logistic regression model for n-class classification problem. In this case, we can use 1 versus best method. Choose which of the following options is true accordingly. A. We need to fit n model in n-class classification problem. B. We need to fit n1 models to classify into n classes. C. We need to fit only one model to classify into n classes. No need of fitting of model for classification. E. None of above. It is alpha. That is, we need to fit n model in n-class classification problem. In regression analysis, the variable that is used to explain the change in the outcome of an experiment or some natural process is called X variable, the independent variable, predictor variable, explanatory variable, or all of the above. That is A to B are correct. It is E, all of the above. In the correlation coefficient is 0.8, the percentage of variation in the response variable explained by the variation in the explanatory variable is A 0.80%, B 80%, C 0.65%, 4%, B 64%, C 6.4%. It is B 64%. You studied the impact of the dose of a new drug treatment for high blood pressure. You think that the drug might be more effective in people with very high blood pressure. Because you expect a bigger change in those patients to start the treatment with high blood pressure, you use regression to analyze the relationship between the initial blood pressure of a patient and the change in blood pressure after treatment with the new drug. If you find a very strong positive association between these variables, then alpha, there is the evidence that the higher the patient's initial blood pressure, the bigger the impact of meters. Beta, there is evidence that the higher the patient's initial blood pressure, the smaller the impact of meters. C, there is evidence for an association of some kind between the patient's initial blood pressure and impact of the new drug on the patient's blood pressure. Delta, none of these are correct. This is a case of regression fallacy. E, no effect of the drug is noted in controlling blood pressure. Anyone from the class? It is delta. None of these are correct. This is case of regression fallacy. No, none of these are correct. This is a case of regression fallacy. MCQ number 5. In a linear regression problem, we are using R squared to measure goodness of fit. We add a feature in linear regression model and we train the same model. Which of the following is true? A. If R squared increases, this variable is significant. B. If R squared decreases, the variable is not significant. C. Individually R squared cannot tell about variable's importance. We cannot say anything about it right now. D. If R squared increases, this variable is not significant. None of the above. It is C. MCQ number 6. Logistic regression transforms the output probability to be in range of 0 to 1. Which of the following is used by logistic regression to convert the probability in the range 0 to 1? A. Sigmoid, B. Mode, C. Square, D. Correlation, C. All of the above. It is A, that is sigmoid. MCQ 7. Suppose we have generated the data with the help of polynomial regression of degree 3. Now consider below points and choose the option based on these points. Number 1, simple linear regression will have high bias and low variance. Number 2, simple linear regression will have low bias and high variance. Number 3, polynomial of degree 3 will have low bias and high variance. Number 4, polynomial of degree 3 will have low bias and low variance. It is C, that is 1 and 3. Suppose we fit lasso regression to a dataset which has 100 features. X is equal to 1 to 100. Now we rescale one of these features by multiplying with 10. Say that feature is x1 and then we fit lasso regression with the same regularization parameter. Now which of the following options will be correct? A. It is more likely for x1 to be excluded. B. It is more likely for x1 to be included. C. Cannot say anything. D. x1 cannot be calculated correctly. E. All of the above. It is B. It is more likely for x1 to be included. Suppose we have fitted a complex regression model on a dataset. Now you are using this regression with tuning parameter lambda to reduce its complexity. Choose the option below which describes relationship of bias and variance with lambda. In case of very large lambda, bias is low, variance is low. In case of very large lambda, bias is low, variance is high. C. In case of very large lambda, bias is high, variance is low. D. In case of very large lambda, bias is high, variance is high. C. In case of very large lambda, both bias and variance are high. It is C. Regression modeling is a statistical tool for building a mathematical equation depicting how one explanatory and one or more response variables are related. B. There is a link between one response variable and one or more explanatory variables. Several explanatory and response variables are related. Explanatory and response variables are not related. E. All of above are correct. It is B. There is a link between one response variable and one or more explanatory variables. This is E for MCQs, and thank you very much for your patience.